Okay, so this video is to prepare you for your systems of equations test, which will be in Go Formative. And this is actually a practice test that I developed last year. And it's going to walk you through the different types of problems. If you really truly watch this video and you take notes and you attend to like what kinds of questions are going to be asked and what kind of order and what the direction is going to be like, it really is very much a practice test, and it's like a run through of everything that you'll need to take your test. So hopefully you'll take advantage of that. This is like literally what the directions say. So for problems 1 through 4, solve each system algebraically and show all work. It does not specify which strategies you need to use, so you are free to pick the strategy that you prefer. I am going to do what I think is the best decision for me in these problems. But you might disagree and you might want to do the problems a different way. Notice that it does say here that you will need to show all your work. So if you are just dumping an answer, I'm not going to give you a lot of points. Okay. So I know the Delta Math grades your normal, like what you're getting for instruction and your practice work, but like I am going to be the one grading your tests. So make sure you know what I'm going to be looking for. So for this first one, we have negative 4x minus 2y equals negative 12 and 4x plus 8y equals negative 24. It was a problem like this that actually, this was several years ago now, tipped me off to a Photomath, like before the apps were like really, really widespread, because Photomath does this problem in an absolutely insane, jacked up way. And it still does, because I just checked it the other day. So whoever wrote that algorithm still has it solving in a really, really, really weird way. So please, please, please do not Photomath, Mathway, Symbo Math, Math Papa, like nope. Like actually look at the problem and make a human being decision about what the best way to solve the problem is, because there is only one way to solve this problem in a sane way, and it's not going to be what Photomath tells you. So when you're looking at this particular problem, what you really want to notice is that you have the opposites lined up. So you've got your negative 4x and your positive 4x, and they're lined up above each other. That means those are completely ready to cancel out as is. Now you just want to make sure you have like your y's lined up, your equals lined up, and your constants lined up. So there is only one way to solve this problem that makes any kind of sense, and that is to use the elimination method, because negative 4x and positive 4x are going to cancel out. Negative 2y plus 8y is 6y. I should probably be writing with my hand on this instead of my mouse. And then negative 12 plus negative 24 is negative 36. And then you divide both sides by 6 and you get y is equal to negative 6. And it's like literally, that's a 6, guys. There we go. It is literally that fast and that easy to get your first variable. So to try to do it any other way, no, just don't do it. Now, in order to finish the problem, you have to solve for x, which means that you've got to plug that negative 6 into either of the original equations. The top equation is nicer because the numbers are smaller. The bottom equation is nicer because you don't have as many negatives. So it's really kind of like, like which way do you prefer? I think personally I prefer the smaller numbers. I'm not as bothered by the negatives, but some of you guys might personally, like you're more bothered by the negatives. And so you want to make sure that you're plugging it in where you think it should go. So I'm going to go ahead with that top one. And negative 2 times negative 6 is positive 12. I don't know if you can hear this, like a loud plane going overhead. Subtract 12 from both sides, so we get negative 4x is equal to negative 24, and divide both sides by negative 4, and we get x is equal to 6. Make sure that your work is organized in some way that I'll be able to follow what you're doing, which means that like your answers are going to be in a location that makes sense, usually at the bottom, but or at the bottom of a group of work, so that I can follow the thread. The second problem here, this is actually set up for substitution. And when I wrote this, like I did set it up where there'd be like an obvious problem that you should use substitution for, an obvious problem that you should use elimination for. And the reason you know this is set up for substitution is because one of the equations is already solved for y. So what we're going to do is we're going to take this y out, if you see where my pointer is hovering, and we're going to replace that y with negative 5x minus 17. Because y is equal to negative 5x minus 17. And if you watch the videos, you know that that's the whole idea behind the substitution. So we will have in that top equation negative 3x minus 3, and we're taking out the y and we're replacing it with negative 5x minus 17, and that is going to be equal to 3. There are a couple other things you can do there. So some of you might be looking at that and saying, well, what about all those 3's in the top equation? Can we do something with all those 3's? The answer to that is yes, but I haven't really touched on what you can do with it. So if you watch another video and you kind of dig up like another way to solve it and it makes sense to you, then like, yes, there actually is something that you can do with those 3's that makes the problem a lot nicer. But I don't want to like open up a new thing like at the last minute and confuse some people. So, all right, let's go ahead and multiply this through. So we have negative 3x. Negative 3 times negative 5 is positive 15. Negative 3 times 17 is, I don't actually know what, 21, 51. Positive 51. That would be 30 plus 21. Yep, that makes sense. Let me go erase my scratch work. I don't actually want that sitting over there. There we go. All right, and then negative 3x plus 15x is 12x plus 51 equals 3. We'll go ahead and subtract 51 from both sides. 12x is equal to, what is that, negative 48? That sounds friendly. And then we'll divide both sides by 12. That is a 48. And that gives us x is equal to negative 4, and that's halfway there. And then we need to go find y, and the most logical thing to do to go find y is to take our now like value of x and plug it into that second equation there. So we'd have y is equal to negative 5 times negative 4 minus 17. Negative 5 times negative 4 is positive 20, and then 20 minus 17 is 3. There we go. Sorry, I have a cat who is hungry, and if he doesn't get fed, he might eat me, which is not cool. You want to come up and help with the lesson? You're just gonna bite me. I don't know. We'll see what he does. Okay, so for number three, this is equally good for either substitution or for elimination. Substitution because you've got an x value right here that's very easy to get by itself. So you could add 2y to both sides and then substitute that in for the x. Elimination is also good because you'll notice that you have your 2y's that are lined up. The problem is that both of them are negative, and if you want them to cancel out, you have to have opposite signs. Okay, this cat's making me nervous. Hang on. Okay, so both of the methods are good, and both of them require you to do something in advance. Now, I'm going to go with elimination on this, mostly because I don't have a lot of space on the screen to work with, and I think I can get elimination to work with fewer steps. That's really the only reasoning behind it. I'm going to take this top equation and I'm going to multiply it by -1. And then somebody in, I think it was my period 4 class, actually asked when I was doing this on the board in class, they were like, what is that symbol? Like, what did you just do there? It's like an arrow with like a double back on it, like a double tail on it, because I don't want to use an equal sign because that's not how an equal sign functions. But what I am trying to say is here is an equivalent system, like after I've done my multiplication. So, but an arrow also means something in math. It means something when you're doing proofs and logic. And so I didn't want to use a symbol that was already in use for something. So it is like an arrow with a double tail on it. All right, so multiplying through we're going to do like -1 times -7 is going to give us +7, and then -1 times -2 is going to give us +2, and we'll end up with a +13. I opted to multiply the top one by the negative because I knew it could flip all the signs there and give us something positive. So that's what I was kind of going for. So that top equation becomes 7x plus 2y equals 13. And I don't need to do anything with the bottom equation. And now you'll notice that the positive 2y and negative 2y are lined up. And of course, if I add those together, I will end up with them being eliminated. So 7x plus x is 8x. Those guys are eliminated, and we have 24. Divide both sides by 8. That is a different cat. That's making noise right now. But he's not a risk factor for biting, so he's also not hungry because he just had a whole can of Fancy Feast, so he's just being a pain. All right, so now we have to plug the value of x in to find y. I'm going to pick the bottom equation because it's nicer, so we'll have a 3 minus 2y equals 11. Subtract 3 from both sides. Remember that this negative right here is attached to the 2y, so 3 minus 3 is 0, which is great, but this negative is still there. And so we'll end up with negative 2y equals 8. Divide both sides by -2, and we get y is equal to -4. So take a moment, pause the video here if you need to, copy it down. Make sure you're not just blindly copying down stuff that I'm doing, but that you understand the reasoning behind each of the steps. And well, hopefully most of you are getting the idea by now that I don't throw curveballs during tests. So if I prepare a study guide and the study guide is intended to prepare you for the test, I am not going to throw something on a test that's radically different from something that we went over on the study guide. I just kind of feel like that's dirty ball to play with students, so I'm not going to do that. So pause here if you need to. All right, now the last one, this one is intended to require a multiplication. This one is like you really can't get away with doing substitution on this one. I mean, you can, but it's going to be heinous. So for this, we really need to decide, do we want to eliminate the x or do we want to eliminate the y? And there's no right or wrong answer to that. It's what I call like a free question in class. I'll just call on somebody that maybe I'm not, like, they don't like to raise their hand a lot, and I'll ask them basically a question you can't get wrong. Like, do you want to eliminate the x or the y? And whatever they say, like, that's the direction we'll go. Now, there's no right or wrong answer, but there's often a better answer. And in this case, the better answer is the y. And the reason the y is the better answer is because 14 is a multiple of 7. So I can get away with just multiplying the bottom equation by 2. If you choose x, you have to multiply both equations. You have to multiply the x and the y, or the top equation and the bottom equation. X and y. The top equation and the bottom equation. It'll work. It's going to require more steps. So I'm going to take that bottom equation and multiply the bottom equation by 2. Now the top equation we're keeping the same. And the bottom equation will end up with -12x minus 14y equals -20. And just remember, what we're going for, like what determines what we're multiplying by and how, is this. This is what we're aiming for. We're aiming for positive and negative of the same thing, so that when we add them going down, we'll end up with a 0 and it will cancel out. So 8x plus -12x is -4x. And then 4 plus -20 is -16. So we end up with, I know I just said it out loud, but I can't remember what I said. -16, and then divide both sides by -4. And so x is equal to +4. And then you have an option. Some students actually like to do the elimination process again if you're very comfortable with it. And so they'll like kind of not erase this work, but restart the problem and just try to eliminate the x by like multiplying the top and bottom equations by something. Most students prefer to just plug in. So like the top equation is better because it's got all positives, but the bottom equation is better because the numbers are smaller. And again, personally, I'm not as bothered by negative numbers as some of you guys probably are. So I'm going to gravitate towards those smaller numbers, but you might feel differently. You might feel a lot more comfortable plugging the 4 into the top equation. And I would encourage you to do that. Actually, like pause the video and plug it into the top equation and then unpause the video, watch me work it out with the bottom equation, and then our answers should match. And it would be a great way to review. So pause the video if you're interested in doing that. Okay, so I'm going to plug it into the bottom equation. So I'm going to plug in x is equal to 4. And so we end up with negative 24 minus 7y equals negative 10. Add 24 to both sides. And we get negative 7y equals positive 14. Divide both sides by negative 7. And I get y is equal to negative 2. Ta-da! Okay, again, before we move out of this section, and this is the longest section of the test here, just notice like the level of difficulty and the amount of work. So like I'm not going to hit you with something that's much, much harder or much more involved. You're not, if the numbers on this study guide are coming out to integers, the numbers on your test are going to come out to integers. So if you end up with these heinous fractions, you know something has gone wrong. Don't panic if you realize something's gone wrong. Mark that problem, move on to the next problem. Don't let yourself get stressed out. And then once you've answered all the rest of the questions that you understand and you feel better about it, then come back to the one that was giving you a hard time. Okay. All right. Now, problems 5 and 6 on your test are going to be multiple choice questions. They are a different kind of beast. They can be answered by either solving the system algebraically and selecting the answer, or by plugging the answer choices into the questions. So I know none of you, well, unless I end up assigning this video to one of my own students, which I might do, but this is being done for the vacancy class. So you guys aren't like sitting in my class and you're not doing my homework all the time. But one of the things that I'm really trying to emphasize this year is that you don't have to receive explicit instruction in every type of problem in order to be able to answer it correctly. Actually, the key concepts and the foundational ideas of math are really, really powerful. And if you understand the key concepts, those key concepts hold true even when the problems like alter or change, as long as they're in that like same umbrella of families. So the idea that the solution to a system is the value of the variables that make the equation true, that is true whether it is 2 equations or whether it's 3 equations. So here we have what's called a 3x3 system. So it has 3 variables, an x, a y, and a z, and you have these ordered, like these are called ordered triples, not ordered pairs because there are 3 of them, but there's an x, a y, and a z. So if you understand what the definition to a system, like solution to a system is, you can actually kind of come into this by the back door. So what we can do to answer this question is we can take the x, the y, the z, plug them into the equations, and see which one of those makes all 3 of the equations true. It can be a little bit tedious, but it's completely doable. So if you know that something's a little bit tedious but doable, you might want to skip it at the beginning and come back to it, because you know it might take you a little bit of time, but you know you can do it. You just don't want to get stressed out or run out of time. So what I'm going to do is I'm going to start with answer choice A, because I kind of like that one. It's got 2 zeros in it. 0 is my favorite number because it's just so much easier to work with. So I'm going to go ahead and plug into that first equation, negative 4 times 0 minus 5 times 0 minus 18 equals 18. Negative 4 times 0 is 0. Negative 5 times 0 is 0. And so I am left with negative 18 equals 18, which is false. That is not a true statement, and I know I'm not going to pick answer choice A. Now I'm actually going to jump down to answer choice C, because that's the other one that's got the 2 zeros in it, and I'm kind of thinking I can check that one out. I can either eliminate it quickly or I can verify it quickly. Like I'm just kind of trying to zoom in on the things that I think are going to work or not work. So going down to answer choice C, We've got -4 times -6 minus 5 times 0 minus 0 equals 18. Then we have 24, -5 times 0, 0, 0, 0, you know what? Is just zeros are awesome. They're the best thing. Okay. And now if I have to guess, I have a 50-50 shot at guessing it right. And nobody's ever taught me, well, or taught you like how to actually algebraically go about solving this, but you can still come out with the right answer. You just got to have a little bit of patience and probably a good calculator. So now you can kind of decide, and do we want to go with B or D? Remember, it's got to work for all three of them. So you might play a little bit of game. Like if you plug B into the first one and it works, then what you might want to do is plug D into the first one and see if it works. You might want to just try to eliminate answer choices rather than verify that one of them works for all three, because that can take a while. So let's go ahead and we'll check out answer choice B. So we have -4 times -4 minus 5 times 0 minus, ouch, -2. That's not friendly. -4 times -4 is 16. The middle part drops out. Negative of a negative, the opposite of an opposite, is adding, and that one actually works. Now, what that means, it doesn't mean that B is the right answer choice. It just means that B has not been eliminated. So I have two options. I can take the -4, 0, -2, and I can plug it into the next equation down, because in order for it to be the solution, it's got to work for all three of them. Okay? Or I can take my answer choice D and I can plug that into the top one and see if I'm able to eliminate D. I'm going to opt for that second one because I don't really these are just big numbers and it's going to be a little bit tedious. So what I'm going to try to do, and I honestly don't remember the answer to this problem, is I'm going to see if I can eliminate answer choice D rather than verify B on the other ones. All right, so let's check that out. So I'm going to try D. -4 times -3 minus 5 times 0 minus -3. See if that's equal to 18. 12. I love zeros. Zeros are the best thing ever. They're like the happy numbers. Okay. So what happened there is that I ended up with 15 equals 18, which is false. And then what I just did was I eliminated answer choice D. So therefore, we are totally on board with answer choice B on that one. And then, it's the kind of thing, if it's a really high stakes test, like if this were the SAT or something, you'd probably want to go and just make sure that B worked in the other two as well, if you have time. This is a pretty solid way to do it. So that double checking is only it's only just to kind of build up your confidence level. So that was the strategy. So there are going to be two problems on your test and you can do this, and there will be multiple choice, which means I am not going to look at your work for it. So you're not going to show it to me. You just need to figure out how to arrive at the right answer choice. All right, 7 and 8 are graphing inequalities. So these are just straight up inequalities. You will be provided with a graph inside Go Formative, or not a graph, but a coordinate plane inside Go Formative to be able to do these. Please attend to the neatness. Your student laptops are touchscreen, but there's also in Go Formative, there's a tool that will draw nice lines for you. What I need to be able to see though is I need to be able to see the dots that you're using to locate either the line or the vertex of the absolute value function. And then you can use a line tool. There's also a text tool in there. There's also a button to upload photos, which I think some of you have discovered. So there's a lot of different ways that you can input that, which might be useful, especially if you're doing it on a phone or something. It's a little bit easier with a bigger surface. So for number 7, I'll go ahead and put, now again, you'll be provided with a coordinate plane. And I'm not going to go through the mechanics of how you graph a line. I feel like I've had to go over that a lot in my classes. But it has been covered, and there are some videos. If you are watching this and you're like, ooh, crud, I don't know how to graph a line, send me an email. Okay, and I will link you over to a couple videos on how to graph lines. I've done some for Algebra 2, and I've also done some for Algebra 1 that can go back and remediate that. I'm going to graph this using the shortcut. Bravo for me, I didn't put enough tick marks in there. So the y-intercept is a 5, okay? So I'll go up 1, 2, 3, 4, 5, and I do need to see on your test, seriously, need to be able to see the dot there. And then my slope is -4. And then this is one of those situations in math where you do want a fraction because you need the rise and you need the run. And so that is going to be over 1. And so we're going to count down 4 and right 1. And that's going to locate our next point. So I count down 1, 2, 3, 4 and right 1. Make sure I can see the point that you're using. And then there is a straight edge tool in Go Formative. Now, because it's less than or equal to, I use a solid line, and I'm aware that my line is totally jacked up. Hopefully you can do a better one. But again, like if you can show me the points and then your line goes wonky, like I'll know what you intended to do, because I know that you're working on a computer and I know it's awkward. So like I am aware. I mean, obviously I'm aware of it. Mine is awkward. So so don't stress over to that, but show me the information that I need to see there. So because it's an equal to, we use a solid line, and then there's 2 ways you can figure out which side of it to shade. I like using the fact that it's less than, and then what you can do is like kind of put your finger or something on a point on the line and say less than means lower because that's where the smaller numbers are, and then just kind of drag it down, and then you can see what side I'm on. So I know it's going to be this side of the line. The other way you can do it is to locate what's called a test point, because one of the sides is going to be like false and the other side's going to be true. And if you can pick the point 0, 0, pick the point 0, 0, because 0 is awesome. And so 2 zeros is even better. So you can just pick 0, 0 and plug it in. And so you have 0 is less than or equal to -4 times 0 plus 5. And you end up with -0 is less than or equal to 5, which is true. And then so you know this is the true side. So that's the side you're going to shade. For the absolute value, you really do need to know the less than. You're fine. You don't want to learn this math? These people want to learn the math. I don't know if you can hear him or not. He doesn't. He wants to bail. Okay, so remember that this is an absolute value function, and absolute value functions are going to be V-shaped. Okay, and so this requires you to remember your transformations. So left, right, up, down, flip. And so this one, I'll use my little pointer, is going to be flipped over. So it's going to look like that. And it is going to go left 1 and down 3. So left 1, down 3. Left 1, down 3. And it is going to be dashed because the boundary line is not included. You do not have an equal sign there. So left 1, down 3 puts us right about there. Oops. And oops. And so immediately I do not do a dash line. So I'll go ahead and erase that. And we'll kind of go like so. Okay, and it says greater than means above, and so we will shade this side of it. And that would get you full credit. My point is not as well located as I would like. But again, you will have a grid that you can put your graph on for that. Okay, and what we did there is we just did a rolling review of how to graph a line and how to graph the absolute value. We also like rolled in a little review of those transformations so that you can refresh that. Hopefully you learned it well the first time. And again, if you're missing a lesson, email me and I can hook you up with some videos to review what those transformations are. You also might want to check out the review video that I did for the test at the end of the first quarter, because I went into a lot of detail in that video on the transformation. So that probably is the best place for you to look if you need a review on that. All right, 9 is a system of inequalities, and we actually only approach these ones by graphing. So your 9th question on your test is going to be graphing the solution to a system. And pretty much what we do is we graph each inequality separately. So you'll notice that the skills kind of build from graphing a single inequality to graphing more than one. And different colors definitely help. Go Formative will allow you to swap out the colors. So I strongly encourage you, like, try to do that. So for my first one, I guess I will use blue. Oh, we'll use like a baby blue. All right. So that has a y-intercept of 3. So I'm going to clearly label the 3. And then the slope is 1/2. So I'm going to count up 1 and right 2. Up 1, right 2 is going to put me right about there. It is a solid line because of the equal. Whoops, I lost my point there. Right about there. And it says greater than, which means I will be shading above. Second one, we'll use purple for this one. This one has a y-intercept of -1. And the slope is -3. And remember, you probably want that fraction there. So we're going to go down 3 and right 1. 1, 2, 3, and right 1. Okay. It is going to be a dashed line. And it says less than, so we're going to be shading below. Now, before you leave this problem, you do need to indicate clearly where the solution actually is. So it comes back to the definition of a solution to a system. There are the values of the variables, or in this case, points, because the x and the y give you the value of the variables. So the values of the variables that make all the inequalities, in this case, both of the inequalities true. So you've got a bunch of points that make the blue equation true, or inequality true, and then you have a bunch of points that make the purple inequality true. And where they make both is this section right here. So what I would do is I would just draw a little arrow and say that's the solution. And that like indicates that you understand that you're not just generating this really pretty picture, but that you are actually understand what part of that picture constitutes the solution. Like, here are the points that make both of the inequalities true. So your 9th problem is going to be a system of linear inequalities. Now, as we're going through all these problems, what you should be doing is in your head kind of like ordering the problems, like this I'm really confident in, and this is a hot mess. And as you approach the test and go formative, you want to start with the ones that you think are going to be the easiest and work your way backwards to the ones that you are pretty much thinking like this problem is going to be a hot mess. So if you know this one's going to be a hot mess, you're going to save this one to the end or near the end. You're not going to leave it blank, but you're going to strategically order. Hang on. Go ahead. I know you got. Yep. Got. It's got important places to be. But you're strategically ordering them to make the best use out of the time you have and to mitigate any anxiety that you might have about your test. Okay, so we're up to question 9. Question 10. Now, this one, when I originally wrote the study guide, which was probably a couple years ago, it says use the graphing calculator. But like last year where I had DHR kids and I couldn't see them, and this year most of my students don't have graphing calculators, I provided the graph. So you'll notice that I wrote like on the study guide, you will be provided a graph for this. So instead of you having to graph like that system, this is more what you're going to see. So you're going to be provided a graph, and let's see if I can do this fairly well. Okay, bear in mind I am like hand drawing this and it's like a bit of a mess, but 2, 4. I don't know. We'll do this. Okay, I'm gonna totally regret doing that. Okay. All right, so you're going to be provided a graph. Ugh, this is like terrible. And you are going to be asked to state the solution. So I'm just exasperated because my picture is terrible, not because the concept's hard. It's actually, you should probably start the test with this one, okay? It's going to be pretty easy. But pretty much what you're going to do is you're going to locate the points of intersection. So the two graphs intersect there, they intersect right there, and they intersect right there. And then you are going to state the coordinates of those points. Okay, now there might be one point of intersection, there might be two. This one happens to have three. That however many points of intersection there are, you're just going to state the coordinates. So for this one, that first point of intersection looks like it might be like, this is why I'm just rolling my eyes a little bit, because like on your test, they'll intersect at nice places. Okay, I'm just telling you straight up, they'll intersect at nice places. So this looks like maybe 1.32. Okay, negative 1.3. So, oh, wait. So negative 1.32. Okay, this one looks like it's at 1.4 negative 1/2. Okay, so seriously, 1.4 negative 0.5, and this one looks like it's at 1, 2, 3, 3.8 negative 2. Sound good? Okay, but hear me. On your test, they will you'll be provided a graph, and I think it says 10 through 12, but I think it's just maybe question 10, maybe like 10 and 11. I don't think it's through 12. Okay, I just don't think it is. So I don't think it is many, but that's all you have to do. Okay, I'm going to say it again. All you have to do for that problem is find where the graphs intersect and give me the ordered pairs. Whether it's one ordered pair, two ordered pairs, or three ordered pairs. That's all you have to do. Stop the video, write it down, and just say, for the graphing ones, like just find where they intersect and state the ordered pairs. That's it. Okay. Now, don't confuse that with like this point, or like this point. Okay. So sometimes on the graphs, whoever does the graph or the computer program that does the graph put these big dots there. Don't just list where like there are dots. Okay, just because there's a dot there doesn't mean that you should be telling me that there's a dot there. You are looking for the points where the two graphs intersect. Those are the only dots I need. So don't give me any other dots. Write it down. Don't give Ms. Taylor any other dots. Okay, just where they intersect. Okay. Now this one actually has, okay, oh, you notice it said like for 10 through 12, and then this one just says 11 and 12, so I'm pretty sure I cut that down to one question. For 11 and 12, notice the change in the question here, okay? There we have a beautiful change in the question. It just says, how many solutions does the system have? It is not asking you what the solutions are, just how many solutions does the system have. So for something like this, you don't even need to have the numbers on it. And so let's say you have, I don't know, that is misleading, but okay. And so you are asked how many solutions, not what they are, how many they are, how many there are. And so you count them. You've got, I'll count them. Let me put the little highlighter on. Okay. So we'll change the color. 1 solution, 2 solutions, 3 solutions, 4 solutions. The answer to this question is 4. Don't do more work than you are being asked to do. Don't do more. No extra, okay? No extra solutions. Just how many solutions there are, okay? And so I think there are 2 questions on the test that are how many solutions. I'm not really sure how that's like broken up. I should go back and look. I did look at it before I decided to do this video on a Sunday night. But I don't remember what I saw because my brain is checked out. It's the weekend. Anyway, so there's like 4 solutions. Just make sure that you're reading the directions. These problems should be the easiest problems on the whole test. Okay, they really should be the easiest problems. Like when you enter the Go formative and you start looking at the test, seriously, skip down to these ones. Find the points of intersection, write them in. How many points of intersection? Like do these first because they are the easiest ones. Okay. Last one, Larry, Harry, and Barry. Larry and Harry both ordered pizzas from Barry's Pizza for their parties. Larry paid $58.50 for 3 mushroom pizzas and 2 plain pizzas. Harry paid $67 for 2 mushroom pizzas and 4 plain pizzas. How much does Barry's Pizza charge for each type of pizza? If you were in my face-to-face class, you would know that I think these are the dumbest problems on the planet. They're so stupid because Barry has a menu and the menu lists the prices. So nobody would actually write and solve a system of equations to figure out how much Barry's Pizza charges for mushroom and for plain pizzas. It's a stupid problem. But it's not a bad problem to practice writing equations, solving equations, so that you have those skills in place for when you get to like physics and you have like real problems where you have to solve a system. And so we're going to do it anyway, but feel free to roll your eyes and say, this is really stupid. Barry's Pizza has a menu. Because he does. All right, so here's how we do this. So we've got like good old Larry, and Larry's buying some pizzas from Barry. And Larry buys 3 mushroom pizzas. Oh, I have the highlighter still turned on. And he buys 2 plain pizzas. And the total for that is $58.50. Okay, now notice the reasoning here. 3 pizzas times the cost of a mushroom pizza. And then you add to that 2 pizzas times the cost of a plain pizza. And that gives you the 58. So that's why the equation, comes out the way it is. And then Harry is getting 2 mushroom pizzas and 4 plain pizzas, and that is costing him 67. So you will get partial credit just for being able to set up the system. Okay, so don't erase stuff. Like, please let me see your work. I promise I am probably nicer in evaluating your work than you are in evaluating your own work. Okay. So don't erase stuff. Like, set up your equations, even if you trip and fall on the solving of the equations. Okay. Now for this one, I'm going to choose elimination because I don't have any of the variables that are easy to isolate. And I'm going to choose to eliminate the P because 4 is a multiple of 2, and I can just multiply the top equation by -2, and I'll end up with -4p. Okay, so let's go ahead and do that. So we're going to have -6m minus 4p equals crud, I don't know what, $107. Well, -$107. No, wait, that doesn't feel right. 16 plus 1 is 17. 17. It is wrong. Hang on. There we go. And what you just saw there was me make a multiplication mistake. And basically, okay, if you want to know like what was going through my head there is I was like rounding up to 60, and 60 times 2 would be 120, and 107 was too low to account for the $1.50 off. It was just too low. So, stop, go back, just check it. It's not a big deal, but you do want to be paying attention because sometimes you can even enter like the wrong buttons on a calculator, and like you do want to have a bit of a radar that says, ooh, like that number doesn't feel right. All right, and so like that's what happened there. So learning opportunity. So the bottom equation we're going to keep the same. All right, and -6m plus 2m is -4m. That's an m. Those guys cancel out. $50. That sounds right. -50. Now I'm gonna like have to double check. Okay, yeah. double check my work. And then we'll divide both sides by -4. And so the cost of a mushroom pizza is, can you tell I don't have a calculator handy? And I'm too lazy to pause the video to go find one because, you know, I have to have one somewhere. $12.50. Okay, that seems good. You guys can check my work. If you think I made a mistake, you know, first person to email me and say, Miss Taylor, you made a mistake. We can talk to the teacher who's entering your grades and negotiate, which is not me or McDonald. Neither one of us are entering your grades. So that is being done by Miss Antoya. So you can make a case for some extra credit. All right, so there's the mushroom pizza, and then to find the cost for the plain pizza, let's go ahead. I'm going to plug it into the bottom equation because I'm not liking those decimals. So we're going to plug that one in. And 2 times 12 would be 24. And then we're going to have like an extra $1 from the 50 cents tacked onto that. Subtract our 25. I just haven't bothered to change the highlighter on this. Hope that's not bothering anybody. What is that? 42? And 42 divided by 4 is 1050. Okay. Okay. So a plain pizza is 1050. And thankfully, this does make sense. Like it makes sense like that you'd have like the $2 for the extra topping. So you just, yeah, like that makes sense. Okay. Now, if I'm remembering correctly, I want to say that the problem on your test only asks you for one of the pizza prices. Like it's like, or whatever it is. I don't know if it's pizza, maybe it's something else, but like it only asks you for one of the two. So if you find, like, let's say this only asks for the price of the mushroom pizza, then we did not have to do the whole blue section of it because we would have answered the question after the green section. So like pay attention to what question you're being asked, because you don't want to do more work. So if it just says, what's the cost of a mushroom pizza, and you get the $12.50, then you're done. You're just doing extra work at that point. That you weren't asked for. So always read the questions. So this is like, I do know that the Go Formative test is 13 questions and the study guide was 13. Some of those piggybacked different types of problems. You know, feel free. I know we're Ms. McDonald's going to assign some practice problems to go with this to kind of refresh all those skills. So make sure that you're doing that. And you can rewatch this video. If you guys can't access the video to rewatch it for some reason, but you do the Delta math and then you just want to watch this review again and you can't, I don't know how the Delta math works. So if you can't get it, send me an email and I can link you to the review video so that you can just watch the review video again. And good luck on your test. We are totally rooting for you guys. So yeah, and so we'll see you in the next one.